In this video, we'll be discussing the passing package of subject code 21MAT31. So the title of this subject code is Transform Calculus, Fourier Series and Numerical Techniques. So this video is specifically designed for the backlog students of 21 scheme of third sem math subject. So I have covered all the important questions from exam perspective. I have compared the previous year papers and entire notes is available with proper explanation. So one by one we'll discuss all these topics. Okay, so first one we have is second order differential ordinary differential equation and calculus of variations. So these two topics together you can easily score 20 marks. Next we have is numerical solutions of second order differential equation. Here again you can score 20 marks. I would say that these two are the passing packages. So this is module 5 and this is module 4. You can easily score 20 here. Next, coming to module 3, it has two large topics, that is Fourier transform and Z transform. Out of these two, I would say that there are few easy topics also. You need not cover entire thing. Okay, so there are certain easy topics which you can cover and thereby you can easily score at least 10 marks in this. Next we have a second module, that is about Fourier series. Fourier series is a difficult topic, I know, but learning few the end part of Fourier series where you are making use of the harmonic analysis, half range Fourier series and all those things, you can easily score 10 marks again here. Next, coming to module 1, Laplace transform. Again remember the formulae, and any question if they have asked, just write the values, or even in the inverse also just write the same inverse formula. You can easily score 10 marks here. So I would say that if you are speaking about the passing package, then fifth module, fourth module are must, and after that covering slight topics, few noted topics in these three modules can help you pass this subject. So let's get started. First we'll look into module 5. So module 5 is about numerical solution for second order differential equation and calculation of variation. So under this first topic which we have is RK method. So RK method is very easy. For any given equation, let me explain it with an example. So for any given equation, they'll give this equation, okay, and the values would be given. Y0 is equal to 1, y dash of 0 is equal to 0. They are asking us to find y of 0.1. They are asking us to find the function when x is equal to 0.1 or the step size is equal to h is equal to 0.1. So here y of x naught is equal to y naught. So x naught is 0 here, y naught is 1 here. Next, y dash of x naught is equal to y dash naught. So here x naught is 0 and y dash naught is 1. Right. Y dash naught is 0, sorry. So thereby we have got x naught, y naught and z naught. Y dash naught, y dash of 0 is equal to z dash of 0. The same thing, okay, or is equal to z of 0. Okay now. So here they have given us the equation. They are asking us to find RK method of fourth order. So this equation is given. In this equation, dy by dx I am putting it as z, and d square y by dx square I am putting it as dz by dx. Now I'll write the formula dz by dx minus x square z minus 2xy is equal to 1. Now I am sending this all these things on the other side and I am getting dz by dx formula. So it will be 1 plus 2xy plus x square z. So here dz by dx can also be written as g of x comma y comma z, and at the same time z can be written as f of x comma y comma z. Okay, so this g of x comma y comma z and f of x comma y comma z are written here. Now what I'll do, I'll substitute all the values which I have obtained in this formula. Okay, k1, k2, k3, k4. In order to find k1, I should require h, x naught, y naught, z naught value. Next, L1 I have to find g of x naught, y naught and z naught value. Next, in order to get k2, I should get the value of k1, L1 and h. Similarly, I will have to find the values of k1, k2, k3, k4 along with that L1, L2, L3, L4. After finding all these values, now I will calculate this, the final solution, that is y of x naught plus h. Here h is 0.1, x naught is 0. So y of 0.1, that is what they have asked us to find, right? So y of 0.1 is equal to y naught plus 1 by 6 times of k1 plus 2k2 plus 2k3 plus k4. If they have asked y dash of 0.1, in that case I have to take this y dash of x plus h, x naught plus h. So here it would be z naught and all L terms here. So here K1, K2, K3 along with that L1, L2, L3 are being calculated. K3 is here, L3 is here, K4 is here, L4 is here, and final solution I am finding it here. So guys, if you refer the 21 scheme paper or question paper, you can see that the first question was about RK method only and it was for 8 marks. So I would say that don't miss this RK method. It is very simple. You have to just remember these formula and it is in a sequential order. Okay, so 1 if you remember, 2 if you remember, you can write the next 2 very easily. So this RK method could be asked for 7 to 8 marks and this question is important and this question is also important. So I have marked these two questions. Along with that, you can refer this question also. So do check that out. Next we have is Milne's method. Milne's predictor and corrector method. So this is again a very simple topic. Here they'll give the values of x, y, y dash and they'll give us a equation. We have to find the value of we have to find the value of they'll tell compute y of 0.4 or 0.8 something. So here we have to find the value. So this entire thing is given and this equation is given. We know that d square y by dx square can be written as z dash. Here dy by dx can be written as z. So z dash is equal to 1 plus z. So this is the equation which we have got. Now I have written x values, y values. So all this y dash, no, it is equivalent to z. That's what we have seen previously. So here it is z0, z1, z2, z3. Same things I have written. And now in order to calculate the z1, z dash, it is equal to 1 plus z. So here all the z values I am substituting subsequently. After that I will get the value of z0 dash, z1 dash, z2 dash and z3 dash. So here the z dash formula I am getting from this z dash is equal to 1 plus z. I hope you have understood this step. Okay. Next we have the Milne's predictor formula. In order to calculate this, after finding all these values, I'll calculate this. Y4 of p is equal to y naught value we know 1 plus 4h by 3. H is the step size. Step size means any two x values if you take 0.1 minus 0 you get 0.1 only. So this difference between any two consequent x values will give us the step size. 4 times of h by 3, 2z1 minus z2 plus 2z3. Substitute all these z values here, you get one solution 1.5835. Next, z4 of p. Z4 of p means it is z dash here. Same thing you do here, you get 1.9835. Now we are checking if the predicted formula is correct or not. We are cross checking it here. Okay. So y4 of c is equal to y2 plus h by 3 z2 plus 4z by 3 plus z4. We get this formula or we get this answer. Now one tip guys, if you are if they have asked only y of 0.4, then you have to find only y4 of p. You need not find z4 of p. So once you find this y4 of p, no, next step would be to write the corrector formula. You write the formula, you write the values, don't calculate it, simply write the same answer here, because predictor and corrector both would be the same only, right? If not, they won't give that question only. So thereby you can save time here. So if they are giving a choice between RK and Milne, I would say go with Milne's method because it is very easy and very simple calculations and you can save time also. Next, here again this question is important. This question you can try it out. Next we have the Euler's equation. Euler's equation, there are two parts. Either the proof could be asked, so they can ask derive the Euler's equation for 6 to 7 marks. Okay. So this is very important. Go through the derivation, nothing to explain, just remember it. Okay. So here I have written little elaborate with proper sentences. If you have any other derivation where it is just very precise, go with that. So that is first part. Next we have numerical on Euler's equation. So there will be a question on Euler's equation. So it can be asked like find the curve on which functional it is. So the functional would be given and the values would also be mentioned here. Okay. So let's see this. Let's see one question. So here they have asked us to find the extremal of the functional. So this is the entire value which they have given. So let me just explain what does the Euler equation say. Euler equation says that integral, the necessary condition for this integral, that I is equal to integration of from x1 to x2 are the values f of x comma y dash into dx is equal to where this integral has to follow the necessary condition where y of x1 is equal to y1 and y of x2 is equal to y2 are the extremum such that dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. If this condition is satisfied by making use of these two conditions, then we can say that uh, this integral is obeyed. So this entire thing could be generalized as Euler's equation. So this is the simplest way one can explain what Euler's equation is. So guys, don't focus on what it is, just remember the derivation and look at the question. So this integral which they give, we have to equate it, I is equal to this entire thing. Now I know f of x comma y dash is equal to whatever the equation they have given, y dash plus x square y dash whole square. Now I'll write dou f by dou y. So here is there anything related to y? No. So it is 0 directly. Next I have dou f by dou y dash. So I am integrating with respect to y dash. So when I am integrating with respect to y dash, here this y dash would become 1 and here x square would be as it is and y dash square would become 2y dash. Yeah, 2y dash. So here I have written 2x square y dash. So I hope you have understood this step. After calculating dou f by dou y and dou f by dou y dash, next step is I have to substitute in this Euler's equation, right? So dou f by dou y minus d by dx of, I am differentiating it. What did I differentiate? This integrated value, it is dou f by dou y dash. So d by dx of 1 plus 2x square y dash. I am integrating the above equation. When I integrate, I get k1 as the constant here. This is gone and minus is remained as it is. Now I'll write in terms of y dash. So I'll send all the things to that side. Y dash would be equal to k1 minus 1 by 2x square. Now here y dash is there. So again if I integrate, it will become y, right? So I have to get the answer in terms of y only, right? So when I again integrate it, first k1 was the constant. Next I have this entire thing k1 minus 1 by 2 x square, I am integrating it. So integral of 1 by x square dx plus a constant c 2. When I am solving this, k1 minus 1 by 2 is outside. Integral of 1 by x square is minus 1 by x plus c 2. Now I am considering this k1 minus 1 by 2, this entire thing is c1. So it is minus c1 by x plus this c2. So this way I have found out the solution. That is the extremal of the given function. It goes the same here also. Again, here also again we are doing the same thing. Here we are dealing with the auxiliary equation and writing the solution in the form of ordinary differential equation and finding the CF plus PI formula. I hope you remember this from the second semester. If not, just doing this till this part and writing the formula can also fetch you at least 3 marks if it is for 7 marks. Okay. So this question is again very important. Next we have application of calculus of variation. So under this geodesics topic, there are only 3 questions. You remember these 3 questions, you will be done with this module. So this is the first question, very easy. Next this question. Next we have this question. So you have to learn these 3 questions, okay? So because in these 3 questions any one would be definitely asked. If you check the 21Scheme paper, in that one question was there on Euler's equation on both the sides, in the 9th A and 10th A, in both the sides Euler's equation question was there, and in 9th they had asked us to derive the Euler's equation also. So if you have studied only Euler's equation, no, you'll easily get 15 marks out there, and rest 6-7 marks were there from the RK method. So RK method is again very simple. So I would say that 5th module is very easy, guys. Don't miss 5th module. Next, moving on to 4th module, it is all about classification of the second order partial differential equations. We'll look into the finite difference approximations, then solving the Laplace equation using 5-point formula, and then heat equation and schematic explicit formula, Crank Nicholson's method, and then solution to wave equations and the problems related to wave equations. So this is all about the topics which are there in fourth module. We'll look into the important ones now. So firstly, all this is for your understanding, leave that aside. So here we have, if given a point, how do we calculate the pivotal points here? Okay, so here we have the formula. Just go through this. Okay, and then first we have a 5-point formula for the Laplace equation is of the form d square u by dx square plus dou square u by dou y square is equal to 0. Okay, so leave all those things aside. Here we have the diagonal 5-point formula. So if this point is there, we'll look into the diagonals. Okay, so this diagonal, this diagonal, this diagonal, this diagonal, we'll add all those diagonals and divide it by 4. Okay, so here will be, suppose, yeah, so here the formula is given this way, right? Suppose if I am calculating for this point, okay, so diagonals would be this, and I'll divide it by 4. Okay, suppose if I have even number of squares, so this was for the odd number of squares, and here this was for 9 boxes. If it is there, then we look into the above part, and here if I have 16 squares, then I'll make use of this. Here again it's the same only. In order to find the value of this, first if I'm taking for this point, it is this, right? In order to find the value of this, I have to calculate this. In order to calculate this, I have to calculate this. So in order to get this, so it's like 2 steps here. First I am finding the extreme points 1, 2, 3, 4, and after that I am finding the value of this point. Okay, so Laplace equation they have given, they are asking us to solve this following square mesh. Okay, so firstly, this u5 is there. In order to find this u5, I'll make use of these extreme points, and I'll find the u5 value, that is 12.5250. After that, I'll make use of the 5-point formula here, u1, u3, u7 and u9. In order to, I'll find these. Okay, so again first I found this, next I am computing these values. After that, by making use of these, I'll be computing the values of the rest of the points, and I hope you know this, it is very easy. So first start with 5, then move on to 1, 3, 7, 9, then move on to 2, 4, 6, 8. That's how you can solve a even numbered mesh. Okay, it is very easy. And here if it's odd numbered mesh, here we'll be making use of firstly finding this u1 value. So for that, this 20 plus u2 plus 100 plus u3, so I'll get u2 u3 in a way one equation. Again for u2 I'll get one equation, u3 one equation, u4 one equation. Combining any 2 equations, I'll solve it, and using this 5th equation, I'll solve it with the other equations. So thereby, by solving these equations, you will generally find 1 or 2 values. Using those, you will again find the rest of the values. So I would say that if you get a odd square question, no, go with the odd square question, because it is very easy here. You'll have to solve the equations by making use of calci, right? So this is again an even square, very easy only. Next we have numerical solution of 1D heat equation. So here either the equation could be asked or a problem based on the equation could be asked. Okay, so this equation is important. Just go through the equation, and yeah, this Bendress-Kemed explicit formula is specified here, and a question on the numerical, a question on the heat equation could be asked. Just go through this. It's again very easy, guys. Next we have the wave equation, heat equation, solving using Crank-Nicolson method. Again, this is also very easy. For this point, this, use that and solve it. Very simple, right? Next we have wave equation. Wave equation, just go through the equation. And how do we solve this? By making use of the Kemed explicit formula. Again, this is very easy formula, and that's it. You'll have Bendress-Kemet formula. It is very simple. So I would say that fourth module and fifth module are very easy, guys. In fourth module, they can ask us to check if the given equations are partial differential equations or not, or solve using the given boxes, that is the table format, or given an elliptical equation, we have to solve the square mesh, and they can ask us to make use of the heat equation or wave equation and then solve the questions further. Next, coming on to third module. Third module is slightly trickier, guys, because it is not that easy to score 20 marks in third module. Provided that you remember a lot of formulas, you'll be able to get that. First formula is this Fourier transform ft, and inverse Fourier transform just opposite of that, and Fourier fct, Fourier cos transform. This is the formula, and inverse of Fourier cos transform 2 by pi of fcu cos ux dx is equal to f of x. Fourier sine transform formula is given. Now they have asked us to find complex Fourier transform of the given function. So this function is given, we have to evaluate integration of sin x by x dx. So given Fourier transform, I'll write it first here. F of u, I'm taking it as f of u here, or f of x. So f of u is equal to integration from minus infinity to plus infinity f of x e to the power I u x dx, right? So here f of x value, if it is if it is greater than or equal to a, then it is 1, and if it is less than a, then it is 0. Okay, so here that's what I've specified here. So I can write f of u is equal to integration from minus a to a, f of x is 1, right? So 1 into e to the power minus ux iux dx. Solving this, integrating it firstly, so e to the power iux by iu, write it down, and from minus a to a. Here taking out this constant 1 by minus iu, and here e to the power minus e to the power iua minus e to the power minus iua, because I am substituting the value of a in the place of x here. Solving this, I'll get cos ua plus sin ua minus cos ua plus I sin ua. Solving this, we get this formula f of u. So after getting f of u, they are asking us to evaluate, right? We will make use of inverse Fourier transform. Inverse Fourier transform, this is the formula, 1 by 2 pi of f of u e to the power minus iux dx. So this f of u, whatever I have got, 2 sin ua by u, I am substituting here, and e to the power minus iux is written as it is. Firstly, I will put x is equal to 0, then I will get 1. When u is equal to 1, I will get sin u by u. So for f of 0, so I am calculating 1 by pi in minus infinity to infinity sin u by u. Here 1 is there because it is a power minus iux is 1 du. When I solve this, when I want just sin u by u, I'll substitute, I'll send all these things as that side, right? So here I'm changing from u to x, and this is the formula which has to be used when we are dealing with f of x, that is even from minus a to a, if it is there, and f of x d of x is, I'm integrating it, I can write it from 0 to a f of x dx, provided that it is even. So solving this, 2 by pi 2 by pi I am writing and changing u to x, and this is how we can solve. So I am getting it as pi by 2. That is the answer for the given question. Evaluate this. No, it is pi by 2. Okay. So again, this is one more question. After finding the value of f of u, in order to evaluate, you have to find out inverse Fourier transform. If you do till f of u only, no, you will get at least 4 marks, because these questions would be of 8 marks. Okay, so both divided into half. Okay, so you can easily solve till f of u finding problem, I guess. And the questions which are there in this PDF, don't miss them at all. Okay, so first you cover these questions, then you can look into other questions. Okay, so this question is also very important, and 1 minus x square. So next, this f of x is equal to e to the power minus mod x. So again, this either they can ask this way, or they can specify all the values like this and ask us to solve. Then this e to the power minus a square x square, again a very important question. And this Fourier cos transform of 1 by 1 plus x square. Cos transform, again the same, the formula here just varies. Just substitute it and solve it. Okay, very easy. Next, inverse transform they have asked. So again, when we come to inverse questions could be asked. So either see, first Fourier transform question would be there, evaluate would be there for 8 marks. Either they can ask Fourier cos transform, Fourier sine transform. Then we have inverse Fourier transform, direct, only inverse Fourier they are asking. So these are the only 5 types of questions which could be asked from Fourier transform. So inverse questions are here, just go through this. Next, coming to Z transform. Guys, Z transform, this is the first formula which is very important. Zt of un is equal to summation of n is equal to 0 to infinity u of n z to the power minus n. Okay, so these are all the properties. This is the damping rule. Just go through this. Next, coming to the important page, right shift formula, left shift formula, and these are the some particular cases. And this is the most important list of formulae, because there will be like at times, no, they can give 3 sub problems and ask you to solve this. It would be for 2 to 2, 6 marks. Okay, 3 sub problems could be there. So by making you, but if you know these formulae, you can easily solve it. By this, if you are knowing the Z transform value, you can easily find out the value of Z inverse also, right? So I would suggest you to properly by heart these values. Okay. So for example, here this question, e to the power minus an. In order to solve e to the power minus an, Z transform of e to the power minus an, I am taking e to the power minus a to the power n. So here I am substituting e to the power minus a as k. So e to the power minus a as k, k being a constant, k is here zt of kn. Zt of kn is z by z minus k. So here z by z minus k is e to the power minus a. Directly I am substituting the value here. So these are all very simple, guys, very easy. Next, very important in Z transform, first one to remember in Z transform is this list of formulae, right? And this main equation, damping rule. Next, the most important is they'll ask us to find the Z transform of cos hn theta and sin hn theta. There are 2 possibilities here. Either this could be asked, or cos n theta or sin n theta can be asked for 7 marks. Guys, this is again a derivation type, very easy. So as I told, cos hn theta, sin hn theta, cos n theta, sin n theta asked. So this question was actually asked in 21 scheme paper, in our question paper. Z transform of n plus 1, again very solve this n plus 1 whole square, n square plus 1 plus 2n. So here we can write Z transform of n square plus Z transform of 1 plus Z transform of 2n. So Z transform of n square, this is the formula. Z transform of 1, this is the formula. Z transform of 2n, this is the formula. Solve this, you'll get this equation. Simple, guys, very simple. Sin 3n plus 5, this is similar to sin a plus b. Expand this, you will get the answer here. Next, we know the value of this Z transform of sin 3n and Z transform of cos 3n. Solving this separate, you will find the answers here, and then substitute it, you will get the answer. Again, this is also important. This was asked in the paper, I guess. This is there in our question paper, I guess. So just go through this. Yeah, this much only, guys. Z transform, very easy. I have told you the standard questions and standard topics to remember. Next, we have inverse Z transform. In inverse Z transform, again, whatever the Z transform formula are there, just inverse of it. These are the formulae. Next, we have partial fraction method to solve. So find the Z inverse of given question. So the question would be given here. To solve this, we'll be making use of partial function studied in 12th standard. So a by, so we'll split this into parts, okay, partial fraction. So I'll take a by z minus 1 plus b by z minus 2. I'll multiply z here and z here, and after that I'll take z outside, cancel it. So I'll get 1 by z minus 1 by z minus 2 is equal to a by z minus 1 plus b by z minus 2. I'm equating all these values to the other side. So here 1 is equal to a by z minus 2, because here z by z minus 1 is there in the denominator, and b by z minus 1. Okay, I got this much, the second equation. Now I'll do trial and error. So z is equal to 2 if I put, I will get b is equal to 1, and z is equal to 1 if I put, I'll get a is equal to minus 1. After finding the value of a and b, here I'll write the equation taking z is taking inverse z transform on both sides. So I have found the z transform till here. Now I have to do what? Inverse, right? So z inverse of u dash of z. So this is the question which they have given, u of n, which is equal to minus of z transform z by z minus 1. So we know z by z minus 1. What is the z by z minus 1? It is 1. It is constant. So I am writing 1 here, plus z transform inverse of z by z minus 2. So z transform of z transform inverse of z by z minus k. Here 1 is k, right? It is k of n. So it is minus 1 by n. And here it is z by z minus 2, that is 2n. So here plus is there, as it is I have written. So I would say that inverse z transform by making use of partial fraction is again very simple, guys. Just finding the values of a's and b's and then substituting it, applying inverse z transform. Here again the same thing, okay. Here again same thing. That is first type. Next we have is this power series method. Power series method is slightly difficult compared to the above one, but in power series there are standard questions, okay. So first one is this log of z by z plus 1. They'll specify to make use of power series method. In order to use power series method, we should make use of these three expressions: 1 plus x to the power n, log of 1 plus x e to the power x. So these are the expansions of these series, and by making use of these we have to put u dash of z in the form of this, and then required z transform we have to calculate. After finding the u dash of z, find out the inverse transform of that. So here just go through this. It is very simple only. These two questions are there. Just understand these two questions, and we have applications of z transform. Again very easy case. So here again partial fraction topic only we are using. So firstly we are finding the z transform from this given equation. We are deducing it into this type, and after that we'll be finding the partial equation, partial form. After finding the values of a's and b's, write the equation, take inverse, solve it, you get the final answer. So these two questions are important, and third module is done. So in third module they'll ask us in Fourier series part, we are clear. In Z transform part we know first Z transform formula is important. In inverse there are two methods and applications of Z transform, look into that, and inverse Z transform formula is important. Solving the Z transform questions are again important. So this much, this is only about the third module. I would say that you can somehow score 15 marks if you study only the topics which are mentioned in these notes, okay. I'm not telling you to look the other material also. Only if you cover these notes also, you can easily score marks here. Next we have the most difficult, I would say, that is the Fourier series. In Fourier series we have this main equation, f of x is equal to a naught by 2 plus summation of n is equal to 1 to infinity. There will be a cos part, there will be a sine part. In order to find the this constants a naught, a n, b n, we have formulae here. So here we have odd function, even function. If f of x, given this condition, if I substitute this condition in this f of x, if I get the same f of x back, then it is even. If I get minus, then it is odd, okay. So when it is odd, I can take, when it is odd function, then I can take a naught as 0, and when it is even, I can take Bn as 0. So if I am taking A0 as 0, this entire thing would be 0, and Bn as 0, this entire thing is 0. And when dealing with a discontinuous function, so these are all the values, and integration by Bernoulli's method, again this is important. These are the formulae, just go through this. And this is, there are two basic problems from 0 to 2 pi interval. So x square question, a standard question which could be asked. Just go through this question. Next we have pi minus x by 2. This question was there in the paper for 6 marks, and they'll ask us to find reduce in this part. Okay, so firstly, when I check if it is odd or even, half of the problem would be solved there itself. For example, here I am taking this f of x, pi minus x by 2. I am substituting the 0 to 2 pi is there, no? So 2 pi minus x formula, 0 comma 2 pi minus L. So this format I am substituting it, 2 pi minus x. If I get f of x back, minus f of x I am getting back. So it is an odd function. If it is an odd function, a0 would be 0. If a0 is 0, I will have to look only into the bn part. So for bn, I know 1 by pi, 0 to 2 pi, that is the limit given here, right? F of x sin of x dx. So here 0 to 2 pi, pi minus x by 2 sin x dx. So I am using the Bernoulli's principle, taking 1 by 2 1 by 2 pi outside, then pi minus x I am taking it as u, and sin x dx I am taking it as v. Solving this using Bernoulli's equation, I'll get 1 by n. After getting 1 by n, I have to substitute the values here, right? So a0 by 2 is 0, and this entire thing is 0 because it is an odd function, and here I got 1 by n sin nx. I am integrating it, I am summation of n is equal to 1 to infinity. On the other hand, I have f of x as pi by 2, pi by x, pi minus x by 2 is equal to this thing. When I put x is equal to pi by 2, I get this entire thing, right? That is pi by pi minus 4 or pi by 4. When I am putting it as pi by 4, I am getting this entire thing, pi by pi minus 2 by 2. Next we have this question for again 0 to 2 pi interval only. Same thing, guys. After finding the value till here, after finding the required Fourier series, you have to substitute the x value which they are asking here in order to get in this format. Same thing, guys. It goes the same. Next we have as minus pi to pi. Earlier we saw from 0 to 2 pi. From minus pi to pi, the formula will vary slightly. Again here I am checking x. This is one question where it is x plus x square. They can also ask x minus 1 whole square for the series of 0 to for the series of minus 1 to 1 or something like that, like this, or minus pi to pi. They can be asked. So again, these three are the conditions. So again, first, so write the equation, find a0, find an, find bn, substitute in the required Fourier series, put the given conditions and solve it. Next I have minus L to L, that is minus 1 to 1, as I told, no, like that. So x square they have asked. So here again, if it is a even function, then bn will be 0, a0 and an only I am calculating. So guys, in Fourier series, first check if it is odd or even, and after finding if it is odd or even, if it is even, then bn 0, if it is odd, then an 0. Till this much also if you do, and if you write it is a even function or odd function, and if you write the next part, bn is equal to 1 by pi 0 to 2 pi f of x sin of x dx, till this much also if you write, and if you substitute the formula, no, if it is for 8 marks, you'll get at least 3 or 4 marks. Solving it further, if you don't know the Bernoulli's equation, solving by part, by fractions, leave, no problem. Till that part only if you write also, no, you'll get marks there. Required Fourier series, yeah. So x cube, interval is specified here, minus L to L. So again, this is very easy, guys. Then we have half range. Half range again, from 0 to L by 2 it is k of x, and from L by 2 to L it is k into 1 L minus x. So again, in parts you are writing from 0 to L it is this, but here we are again dividing it into parts, 0 to L by 2. So 0 to L by 2, we are solving it here. So yeah, that's how it is. And on the other side, L by 2 to L, further we are solving it. 0 to L by 2, L by 2 to L. Solving it by parts. It is again very simple, guys. Just the normal integration and solving it here. So here again, Lx minus x square, till this much it was for half range Fourier series. Coming to harmonic analysis, this is slightly easier compared to the previous part. Here you will have to calculate A0, A1, A2, A3. If they are asking the second harmonic, third harmonic, fourth harmonic, so you have to calculate till here B1, B2, B3. So here they have asked us to find up to second harmonic. So the values are specified here, observation n value is specified here. Make a table x, y cos x, y sin x, y cos 2x, y sin 2x, because they have asked us to find till second harmonic. If it was third harmonic, then it would be y cos 3x, y sin 3x. So in order to calculate that, so for B1, B2, it is y sin 3x, right? So in order to get these, we have to calculate these values. In order to calculate those values, we are making this table. After doing this table, do summation of the entire thing. For A0, it is 2 by n summation of y. Summation of y is 26 here. 2 by 6 of 26.9, you get some value here. That's how you do for the entire thing, and now you will write the required Fourier series. That is A0 by 2, A1 cos x, B1 cos x, A2 cos 2x, B2 cos 2x. Because they have asked till second harmonic only, I have stopped till here. If it was third harmonic, A3 cos 3x plus B3 sin 3x. Here, like here, it is third harmonic, no? So y cos 3x, y sin 3x, then calculating A3, B3 and substituting here, you will be done with it. So harmonic problem, don't leave it, guys. It will be definitely asked for 7 to 8 marks in our paper. Both the questions, for example, the third question and fourth question, both sides also we had this harmonic question. It was in one question, it was just asked to find till first harmonic. See how easy it is. Next, on the other, in the other question also, it was asked to find up to first harmonic only. Again, 7 marks, very easy. Don't leave this topic. Coming to first module, it is Laplace transform. So this is the main equation of Laplace transform. Remember this. Next, these are the standard results. Leave all those things aside. Look into this part. You have to remember this in order to solve it further. These are the formula of sin cube theta, cos cube theta. Next, there could be questions like these to solve using the formula, substitute the value and solve it. Again, this is simple, easy. Next, very important is these properties. One question for 6 to 7 marks based on these properties could be asked. So in order to solve these properties, you will have to make use of the previous formula. Okay, the formula which we have seen here. So first you should remember these formulae, practice these questions. After that only you will jump into the properties, and there are property questions also. For example, this is the first property, and here is the second property. T of n into f of t is equal to minus 1 power n by d of n into ds of n. You are differentiating it, L of f of t, the given Laplace transform. So these property questions are very easy, guys. Wherever I have written important or put a tick mark, don't miss that at all. Cover it, solve it properly. Okay. Next we have Laplace transformation of periodic function. So here again there are standard questions. First one is the sawtooth function. If you see kt by t, it is sawtooth function, remember that. So it is important. Then e minus e, this was asked for 6 marks. It is square function. This kt by t, e minus e, and the next one we have is this e sin omega t. This is very important, guys. E sin omega t and 0. This was there in the previous year paper, in our paper. And then this t and 2a minus t, very important. And there can be questions to prove also, like this. And we have representation of discontinuous step function. So step function topic, if you want, you can cover, else leave that topic, guys. It's up to you. Here I've put star. So just go through these topics. Next, I have inverse Laplace transform. So inverse topic, again very important to remember this formula. The properties would be just opposite of the Laplace transform. In order to solve the inverse part, we'll make use of convolutional theorem. Convolutional theorem is very easy, guys. And if you check the question paper, no, convolutional theorem questions were asked in both parts. In first question also, in second question also, convolutional part was definitely there. So these are the formulae to use for solving the convolutional problem. Just go through these notes. It's very easy. After that, we have the initial value theorem. It is again very easy. By parts, we are partial fraction. We are solving it. Firstly, solving this entire equation, writing it in a simpler form, and after that, A, B, C, solve it and apply inverse Laplace transform on both sides. You'll get the required equation. Very simple, guys. So this is about it. We have tried covering all the important topics, all the important questions. Guys, I would say that cover these questions firstly. Yeah, I know M3 is slightly difficult, but then you've got ample amount of time, and all the best for your exams. You can clear. I hope you clear the exam this time definitely. And if you have got any doubts, if you need any materials, do let me know in the comments. And stay tuned. Subscribe to my channel. Thank you.